Hey guys, so Jason Matthew here from Trinidad and Tobago, and today we're going to be looking at amino acid titration calculations using the Henderson Hasselbalch equation. So let's get straight into it, guys. So the question for today is this: the amino acid histidine has a side chain for which the pKa is 6.0. Calculate the percentage of histidine side chains which will be acidic at pH 5.4, and you have to show all the working. Now let's first of all pull out the important parts of this question. So we're looking at the amino acid histidine. Its pKa is 6.0, that's the pKa of the R group, that is. And you are required to calculate the percentage of how much of that histidine side chains, or how many of the R groups will be acidic at pH 5.4, and your marks wouldn't be really in the final answer, but most of your marks will be in the working on getting that answer. So please show all working. So guys, you know the biochemian way. Write down the question, go try it out on your own, and then come back. I'll be right here waiting to show you the solution for this question. So I'm right here waiting, guys. Go do it. Write it down. So first of all, you have to appreciate that you have to use the Henderson Hasselbalch equation for this question. And the Henderson Hasselbalch equation states that pH is equal to pKa plus the log of the concentration of A minus divided by the concentration of HA. Now what does A minus and HA mean? Well, your A minus is your conjugate base and your HA is your acid. And the question that we're doing here today, you must pay particular attention and make sure that you know what they're asking for. Because the question will either ask you for the conjugate base or the question will ask you for the acid. The question that we have in front of us right now is asking you all for how much of the acid is present. So that's the one we want to concentrate on. So let's look at the amino acid in this question, which is histidine. Now on the left you have the acidic form HA, and to the right you have the conjugate base form A minus. Now this is respect to the R groups. Now let's do a little amino chemistry here. This is your alpha carbon, so therefore this will be your alpha carboxylic group, and this will be your alpha amino group. But what we are really looking at today is the side chain, or the R group. So that'll be this here. And if you watch in the acidic form, there's a hydrogen here. So this nitrogen has 1, 2, 3, and then to this hydrogen 4. So when a nitrogen has 4 bonds, it has a plus charge. And you see in the base, we lose the hydrogen as a proton, and you get the base form. Now the question is asking you, what's the percentage of histidine side chains? So you want to know how much of the histidine is existing in this form, all right, that are acidic. So very important. So let's carry on. So this again is the Henderson Hasselbalch equation. And all I'm going to do in this next step is substitute the values that they gave you in the question. So they said that the pH was at 5.4, so we substitute pH to be equal to 5.4. And they also said that the pKa of the R group was 6.0. So we substitute that value as well in the Henderson Hasselbalch equation. The next step is to make log A minus over HA the subject of the formula. So all we have to do is take the 6.0 and carry it over the equal sign. So when it goes over the equal sign, it becomes minus 6.0. And that's a simple arithmetic there. That's minus 0.6. That will equal 2. Now the next step, you want to find the antilog or the inverse log of minus 0.6. In other words, you want to remove the logs on this side. To do that, you have to find the inverse log of minus 0.6. Now the antilog x is equal to 10 to the power x. So in this case, antilog of minus 0.6 will equal to 10 to the power of minus 0.6. Now in most scientific calculators, the 10 to the power x knob is not the right there on the calculator. You have to work towards it. So let's spend some time talking a little bit about the calculator, because I don't want you to go in the exam and you're getting the question wrong because you can't use your calculator. So the first thing to do is get your calculator and type in minus 0.6 on that calculator. Now be very careful, it has to be minus 0.6. If you just put 0.6, you're going to get a different answer. The next step is to locate your second function button. Now if you have a sharp scientific calculator, that tends to be an orange button that writes second F. If you have a Texas Instruments calculator, it should just write second and it should be a green button. And for those Casio fans out there, you should have a shift button that's either in a light blue or gray or some color like that. Now that button should be at the top left hand corner. So look at the top left hand corner of your calculator and you should see one of these buttons there, hopefully. The next step, press the log button. So by pressing the second function button and then pressing the log button, what you are really doing is activating the 10 to the power x function. And once you press the equal sign, hopefully you should get this answer, 0.25. So the antilog of minus 0.6 is 0.25. So hopefully you got that answer. Now if you see the E or error comes up, what could be possibly happening is that you might have to type in second function log and then type in minus 0.6 and then the equal sign. So for most calculators, you would have typed in the number first, press second function, log, equal. What I'm saying is that for some calculators, you might have to press second function, log, then the number, equal sign. So try those different sequences and one of them should work. So we now know that A minus over HA is equal to 0.25. Now all I'm doing in this line here is putting the 0.25 over 1. And anything divided by 1 is still the same number. So this is still 0.25. So we can say that the A minus to HA is 0.25 to 1. And again, the question still at hand, what percentage is HA? Well, sometimes ratios could be a little intimidating. So let's go back to the basics. A chocolate bar is shared between J and M in a 1-to-1 ratio. How much does M get? Now your brain is already wired to understand this ratio. And without doing any calculation whatsoever, most of us would already said that J will get a half of 50% and M will also get a half 50%. Our brain could calculate 1-to-1. We are wired like that. But what was the mathematical procedure behind it? Let's investigate that. So let's say we took M. So remember G and M is sharing this chocolate bar 1-to-1. So the 1 will be for J, M will be corresponding to 1 as well. So first to calculate how much M will get, you take the number in the ratio that represents M, which in this case is 1. And you divide that by the total of the two numbers. So it's 1 plus 1 multiplied by 100. So in other words, it's 1 divided by 1 plus 1 by 100. And you're going to get the 50%. So that's how we do it mathematically. Now, let's go to the ratio that we have. So your A minus to HA is equal to 0.25 to 1. That's the ratio that we have. Now, look at the numbers that are corresponding to A minus and look at the number that's corresponding to HA. 0.25 will correspond to A minus and the 1 will correspond to HA. Now you want the acidic form. That's what the question asks for. So you take the number that represents HA, which is 1, you divide it by the total of the two numbers, so it's 0.25 plus 1, and you multiply by 100. Now when you work it out, make sure you use the brackets before you multiply by 100, so you're going to get the correct answer. And if all goes well, you should get that your percentage HA, in other words, the percentage that is in the acidic form, is 80%. Now this here is a summary of all that we just did. Because for the exam, you're not going to be talking about chocolate bars. I'm going to be breaking it down like how I did. I just broke it down so you could understand what was going on. But for the exam, this is the solution you want to give. Always make sure and state the equation, because there's always marks there. And then show all your working. Show the substitution, show what answer you got when you did the anti-log, and then your reasoning on how you got, in this case, the acidic percentage. Show all working, because this final mark, this final answer, 80%, carries the least amount of marks. We want to make sure that you know all the working to get the 80%. Now let's look at that same question again, but let's change it just slightly. So we're going to have the pK, again is 6.0. The pH that we'll be looking at is 5.4. But in this case, we want to know the percentage of histidine side chains that will be in its conjugate base. Once again, I'm going to show all the working. So the question is almost exactly the same as before. Just in this case, I just want you to know if instead of getting the acidic form, you're going to get the conjugate base form. Now, yes, I know you could just minus the 80% from the 100% and you're going to get 20% based on the values we had before. But I want to see if this was a fresh new question, how you would deal with it. Now, first of all, we're going to substitute values into the Henderson Hasselbalch equation. So all of this is going to be familiar. And you're going to end up with a ratio of 0.25 to 1 once again. So that was discussed before. But now, instead of asking for the acidic form, we want to know the conjugate base form, which is what A minus represents. So you look for the number that represents A minus. In this case, it's 0.25. You divide by the sum of the two numbers, 1 plus 0.25, and you multiply by 100. So all of us should have this answer now. So the concentration A minus should be equal to 20%. And we already knew that we was going to get that answer. It's just making sure that you can do it both ways. So I'm putting up two practice questions here for you. Give them a try. Now, if you all understood what I did in this video, it's the same principle for any of these kind of questions. Apply the principles and you're always going to get your answer. So try these two questions, guys. All the information that you need is there. So try it out, put up the answers in the comment section on YouTube, and I will take a look at it, tell you if you're going right, if you're going wrong. Now, if you want more information about proteins and amino acids, please go to the Biochem Gem YouTube channel, type in amino acids and proteins, and you're going to get 2 videos about amino acids and proteins, level 1 that is. Take a look, subscribe to the channel. We appreciate all the support. So once again, guys, if this video was helpful, please like the video, send your comments, subscribe to the channel, give us your love. Let's keep the channel going. And again, thank you for listening. I hope it helps. Best of luck. Take care, guys.